Hi Math, I'm Andy. Today we're going to look at differentiation and specifically the quotient rule. Now the quotient rule means when you take the derivative of a function that is comprised of two functions that are being divided by each other. So maybe the derivative of like a rational function or something. So the derivative of a quotient kind of breaks down into this form. You have a numerator and you have a denominator. So it is the function of the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. And so this is kind of a format that we're going to use to find the derivative of a given function. Let's say that we're given the function y equals 5x minus 2 divided by x squared plus 1. So let's say this is our function, y equals 5x minus 2 over x squared plus 1. And we want to find the derivative of this. I want to know what is y prime. Well, one thing that I just want to notice is that y is actually two functions being divided. So if we call 5x minus 2, if we think about that as f of x, and we think of x squared plus 1 as our g of x, one of the things that I notice is I'm going to need those pieces inside of my rule. There's g of x, f of x, and g of x right there. Now I also notice that there's a f prime and a g prime. So just right off the bat, I'm going to take the derivative of f and take the derivative of g and just have those kind of so I can use substitution to help me do this. So if f of x is 5x minus 2, that means that the derivative of 5x minus 2 is just going to be 5. Because the derivative, this is almost like a power rule. The 1 comes down, becomes a 0, and so you just get 5 times 1 times x to the 0, which is just 1. So we're just left with 5, and the constant 2 becomes 0 anyway. Now let's look at g prime. G prime of x is x squared plus 1. There's a power rule here. The 2 comes down, and I end up with 2x to the first power, and then the derivative of a constant is 0 as well. So I have my f, my g, my f prime, and my g prime. I can now just go to my y prime, the derivative of y, and I'm just going to write in these pieces using substitution. So g of x is x squared plus 1, f prime of x is 5, f of x is 5x minus 2, and g prime of x is 2x, all divided by g of x, which is x squared plus 1, quantity squared. And so this is essentially the derivative of y, but we might just want to see if we can simplify anything. So one thing that we can do is do our distributing. Let's just distribute these guys up here, and let's see if there's any like terms that we can combine after doing that. So I have this y prime still, and I have a 5x squared plus 5, and now I have a minus, and this is going to be a quantity in itself. This is 10x squared minus 4x. And so this negative is actually going to be distributed as well. So I'm going to have a minus 10x squared. And then I'm going to have this negative 4x and a negative. It becomes a positive 4x. Now my denominator, I can distribute this and FOIL this if I wanted. But x squared plus 1 squared is probably a better way to have this simplified in my denominator. And then finally, I just wonder if I have any like terms in my numerator that I can combine, and it looks like I do. 5x squared minus 10x squared gives me a negative 5x squared. I have a plus 4x, and I have a plus 5 over, and then x squared plus 1 quantity squared. So the derivative of 5x minus 2 over x squared plus 1 is equal to negative 5x squared plus 4x plus 5 over x squared plus 1 quantity squared. And that's using the quotient rule.